If you would, just start off by telling us a little bit about yourself and how you have come to be here at Strathclyde and how you've come to develop this X-ROTOR idea. And then tell us a little bit about the concept if you like.
Okay. Well, I've been here at Strathclyde for a very long time. This is my 4th decade. And my background before that was I worked for British Aerospace, which obviously is a good training for wind energy because I was doing aerodynamics, I was doing structural engineering, and I was doing control engineering, all of which are central to the design of turbines.
Mm-hmm.
When I came to Strathclyde, I got involved with a local company called James Howden, who were a very successful wind turbine manufacturer. And as I say, the rest is history. I've now been doing that for 40 years, getting on. Well, not quite, but nearly. So over that time, I built up the wind energy group here from small beginnings to one of the largest, was the largest in the UK, one of the largest in Europe, and been very heavily involved with the industry over that period.
Mm-hmm.
So from that work with industry, I became very interested in the design of turbines, particularly novel concepts, which might promise to be better, more use for offshore turbines, bringing the cost of energy down, etc. Okay. The inspiration for the X-ROTOR goes back to about 2011-12. I'd worked on a number of vertical axis projects, and that had taught me what the problems were. So I was motivated to address these problems head on, rather than trying to take a conventional wind turbine and try and do the best you could. It was actually address those problems head on, design a concept which avoided them. So that was the motivation for starting to look at X-ROTOR. And I realised in doing it that we had to bring the capital cost down, and we had to bring down the operational costs down at the same time.
Mm-hmm.
So in the X-ROTOR, if you consider first a conventional wind turbine, it consists of a very large rotor which extracts power from the wind, and a drivetrain which converts that power into electrical power. The drivetrain consists of gearboxes and generators, which for large offshore wind turbines can weigh an order of several hundred tons, and they're situated 100 metres above the sea. On the X-ROTOR, we dispense with the gearbox. The main rotor is free to rotate, it does not drive a generator. Instead, we attach small turbines to the ends of the lower half of the main rotor and the ends of the blades. The reason for doing that is that they see a very high wind speed. There's a strong multiplier effect of the rotor going in and out of the wind, and that in turn means you can have a small rotor which rotates very fast, so you can have a conventional generator without a gearbox. That leads to the very lightweight power conversion, and because it's conventional generators, it's a lot cheaper. So that gives you a big capex saving. The other advantage is being close to the sea. You're sitting 100 metres above the sea, you're 20, 30 metres above the sea, which means you avoid all the costs of heavy lift vessels for doing major repairs. It makes access very easy. And on top of that, the X-ROTOR is a much simpler machine than a conventional wind turbine. So all round, that drives down operations and maintenance costs. So we've got the two, that's how we meet the two requirements. CapEx costs are down and the OpEx costs are down. It has one other very good advantage, which is because of the nature of the rotor, main rotor, it creates more mixing in that atmospheric boundary layer, which has the potential to allow very high density wind farms maybe doubling the number of turbines you would have in a given area. And the implications of that for costs are really quite major, but also in terms of better exploitation of the resource with lower impact on the environment. Within the X-ROTOR project, my role, first of all, is the principal investigator and the coordinator of the project. But I also have two additional roles of that. The second one is that a project where you're developing a wind turbine, a new design of wind turbine, needs somebody who's the equivalent of a chief engineer, who brings together the team who are working on the project in terms of ensuring exchange of information, and everybody's being kept abreast of progress on the different work packages. And there's also an aspect there of quality control and so on. So I play that role as well. But my third role is leading the work package, which is concerned with the design of the control system.